go, here we 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 go.
And I think we are live. Let me check the people that are online. Say hi, where you from, where you're watching us live, maybe which country and what time, part of the world, and what time is over there. Like people watch us from all time zones, in the morning, at lunch, in the afternoon, and people in APJ actually watch us during their night. So this is another episode of Container from the Couch. I want to greet everyone. Just say hi in the chat, and we'll give it a minute for people to connect as we kick off things. So we have a special episode today with the folks from Chkk. Is that pronounced correctly? That it's called Chkk or chicken? I saw a falcon or a chicken. One of those two things will be discussed about in the logo, and people can put in the comments around that. But I think it's a falcon. So welcome, Fawad. Great to have you here. Can you introduce yourself?
Hey, thank you for having me here, Carlos. Super excited to share with everyone who is logged in about what we have built, what we announced yesterday. I'm Fawad Khalik. I'm the co-founder and CTO at Chkk. We've been in business for a while now. I actually was part of the EKS team before I started this.
I was going to say, you have a background on EKS. A thing or two.
Shout out to everyone, Ishwar, Bob, Balaji, Raghav. It's a phenomenal team, and I feel lucky that I was part of that team, and I got to enjoy that ride in the early days, and that gave me the inspiration to leave and even start Chkk. So very excited to be here. And talk about this gnarly paying off infrastructure upgrades.
Yeah, and we're super happy to have you. We do a lot of work with vendors, partners, startups that are like innovating around EKS and helping our EKS customers, right, to take the best out of the EKS clusters under compute and be able to be up to date on updates. And that's the topic of today, right?
Absolutely.
So we want to kick it off with some slides.
Let's do it.
And introduce your product and an organization.
Let's absolutely. We will dive right into.
And folks, stay around because we're going to discuss a little bit of the concepts, but most of the show today is going to be hands-on demos. We're going to see a lot of APIs. We're going to see AI. Which, if you've seen the latest shows that have been driving, AI and MCP are the things that I'm working on. DevOps, AI, running AI on EKS, and Chkk has some interesting aspects around those concepts that they're accelerating how people upgrade their clusters.
Absolutely. So here's the flow we're gonna have today, folks. We'll talk about why infrastructure upgrades are hard. We will share some things that you will resonate with as an infrastructure or platform or DevOps or SRE engineer. Then we'll dive right into a demo where we'll show you using a coding assistant and the upgrade contact server from Chkk and upgrade agent, how we can make changes in my IAC, which is contextualized to my running topology, my running environment. Let's start with the pain points. So you as an engineer, when you're running your applications on Kubernetes, like EKS, for example, EKS has an amazing service, and they have significantly simplified how you run and operate Kubernetes. So what you get at a control plane, and you get nodes, managed nodes, or using auto mode, and you get a bunch of add-ons from networking to CNI, core DNS, to kube-proxy and others that are bundled and packaged with EKS as a service. That gives you some baseline capabilities. On top of that, you have to bring in additional open source tooling or vendor or commercial tooling or even your proprietary tooling to offer all the features to your own application teams. This can be certificate management tool, or service meshes, or databases, or data streams. And what ends up happening is that your cluster is running 10, 20, 30, 40 of these open source projects or add-ons or application services.
Yep. And people have seen the CNCF landscape, right? Is
absolutely
amazing set of products, like 5 products and open source project, right? The landscape, people are not aware in the CNCF landscape is a way to advertise, or it's kind of a billboard where you can find vendor products, open source project, but all based on open standards, right? Linux, containers, Kubernetes, and they're all running Kubernetes. So that's a flexibility that customers look for when they're using EKS, is because they're using Kubernetes software and they're running it, and they want to run it at scale in AWS. EKS is the place to do it. And there's so many projects out there, very useful, but people install a lot of them. Like they go and install a lot of them in their clusters.
Absolutely. So you get that flexibility. You have a platform, you can install any open source software or other software from CNCF landscape. Now come day 2, and now there's work that has to be done to keep them, to maintain them. What happens is that CVEs show up. You have to add new features. EKS has to upgrade 3 times a year. EKS teams cannot, keep supporting you something which was 4 years ago. So of course that is part of maintenance, as part of hygiene, and also part of having a clean, good security posture. They say you have to do 3 updates a year. And the open source projects that you typically rely on, they even require more frequent upgrades or updates, typically 5 to 8 times a year. So the engineers who are running their applications, or managing the infrastructure, are caught in this unending upgrade cycle. It's like being on an upgrade treadmill. And anytime you have to make an infrastructure upgrade, an infrastructure change, not just in your control plane and nodes, but the layers on top. Let's say you upgrading a database, let's say or Istio or Chkk or other components. This is a time-consuming, error-prone, risky, unsafe, work, and it's a tedious work. Why? Because you have to have expert engineers come in, read release notes, figure out what is changing, why it's changing. You have to map it to your running topology. You have to make sure it is compatible with your next version of Kubernetes, and it's also compatible with everything else running in your environment. And then finally, you have some sort of internal guide or a plan. After weeks and months of research, you go and perform that change. And then 3 months later, you have to do it again, and then again, and then again. This is just for tied to EKS releases. Even more frequently, you have to do it when it's open source component. So it's a funny graphic here where an engineer is on this upgrade treadmill, and they have to deal with CRDs and custom resources and helm diffs and dependencies and manual researches, and there's potential breakages. What ends up happening is that as an engineer, this is the ideal world where you want to be working on new features. There are so many new AI capabilities. There are new agents out there. There are amazing MCP servers that you can go play with. Your time is spent on keeping the lights on, operational tasks. And this ends up becoming the current reality, because the work that is done around some of these maintenance tasks is very labor intensive, and it's also mission critical system, so you can't make a mistake. Like if something is mentioned in a release note somewhere, like a flag changing, if you miss it, it's a potential breakage in your dev environment, or even an outage in your production environment.
And I give you like maybe a perspective of for folks that are working with this. So you're in an organization, and maybe you're a platform engineer that you're working with upgrades. It doesn't matter if it's a vendor software that you are putting in your cluster, right? You're paying for that software vendor, or it's open source, or it's your own apps. You have to update them because to have dependencies. But what we're going to touch today is that open source project that you decide to pick up, like Argo CD, Istio, External Secret Operator, which came up lately in LinkedIn. Those are open source projects they have useful software, I would say, good Linux foundation, but the guarantee is, right, and the updates, maybe comparing to a vendor, right? So if you get a a package from a vendor will say, we're going to do CVEs every time there's a very critical CVE. We're going to do that patch, and we're going to guarantee you an SLA that we tested the heck out of it, that for sure you should feel comfortable to do a patch upgrade. And the only thing that it changed was this one liner to fix the CVE. And you feel comfortable, right? Doing that once a month, and then worrying about maybe a minor release. You do it twice a year. Then comes open source. There's no guarantees. It's like, they might say we fixed the CVE, and we happen to have a lot of other PRs in there. So we're going to do the CVE plus this extra delta. And we do the test the smoke test. Like, did it break? But they don't do extensive testing to guarantee to someone, like, if you pick this patch release or this minor release, the risk is so low that you don't have to spend time like worrying about it, or if it's compatible, it's going to fix something else. And by the way, we're not going to do it every 6 months. We're going to do it every 4 weeks. We're going to keep updating. And one of them may have a CVE. So you are in that treadmill. That I think that's the distinction between, taking software from a vendor and taking software from open source. That's the risk that you need to do at the beginning of the year when you decide, like, do we buy or do we use open source? Right? And just my thinking of, like, some organizations are missing that, and they discover that when they have, like, most everyone in the organization, like, what we have done this year, like, only upgrades. Like, where are the features?
Absolutely. It's very nicely put, Carlos. One of our customers, Dexcom, shout out to Sean over there. He described Chkk very well. He was like, I have a small team and I run a lot of open source software, and I don't have the budget to go and purchase enterprise licenses from each of them. So by bringing Chkk in, I have this enterprise like support that my team has. I know when it's going to be end of life. I know when it's going to be incompatible. I know how I have to perform an upgrade in a safe manner, because Chkk gives me all of those things. So yes, I mean, very nicely put. Talking about the work that you have to do, which is labor intensive. This is what ends up being ends up happening to the expert engineers. You guys are the experts on certain topics. You have an expert on Istio. You have an expert on Chkk. You're an expert on MySQL and Kafka and Elasticsearch. The person has spent a lot of time diving deep into that topic, studying it. They know they can identify when something changes. They can go read release notes. They also know you're running topologies. They will go figure out, yeah, this line is potentially going to impact that specific application, and this is the blast radius, this is the impact. This is not a small change, it's a large change. And now the expert engineers are changelog archaeologists, and they have to be involved every single time you're making this change, and that is quite a frequent change. You have to do it like almost monthly. And I'll give you an example.
You mentioned archaeologists, because one thing that I've seen is, and you learn this by getting burned. I want to explain what it is you go and this famous open source project get released, let's say Prometheus, one of them. You go to the changelog, like what is available? 2 pages, right, of changelog. And that's the first, like, you can go over, like, yeah, we're not using that, we're using this, doesn't affect anything. But this is open source, right? It's trust but verify. I was in an organization that we had to change the changelog. Like, that's what they're saying, that they change. I need to go and do a diff between the 3 versions, all 3 versions that I have, and this one in terms of source code, and spend literally, like, I'll be this guy, like, diffing files to see, like, did they actually the change that they did? Because in the changelog, they just put the changelog from the previous release, not the changelog from like mine to 3, the version that I have running in production that I need to patch, that is 3 versions. And I'm going through GitHub repos, like 2 GitHub repos, Git clone, Amazon QC, like, please compare these files and see if there was the delta from jumping to. I'm this guy on Friday, right?
Absolutely. Yep, absolutely. I'll give you an example. This is this is a complex example, but whenever you are upgrading one of these open source projects, and it could be a single hop upgrade, it could be a multi-hop upgrade, HashiCorp console, the OSS version, for example. Let's say you where you kept delaying your upgrade for a while, and now you are at a point you finally have time and you cannot delay it further, and you have to jump multiple versions. And let's say this is an example where you have to jump from version 110, V110 to 118. This is not a straightforward upgrade. Like, you cannot simply go from 110 to 113 because there are schema migrations. You can go from 110 to 112. This is a supported path. 112 to 114 and 116 and 118. This is one of the multiple supported paths. These upgrade constraints are different for every single open source project. For example, Kubernetes, if you're doing in-place upgrades, you can only do N+1 version. And if you happen to have, use other stateful, open source projects, some very complex constraints that you have to go comply with. Some of them even have equations, like Longhorn. If you guys use it, it has equations that you have to go understand. I can go from this specific patch minor version to another, N+1 minor version, but I can also do major version to N+1 major as well. And someone has to go understand it. This is anything but easy. And this is mission critical systems you're running on, on this infrastructure. So we solve that. Chkk solves that, and I'll talk about the technology. How we make it happen. I'm sure you guys have questions. This is a very hard problem, and how does Chkk solve it? In terms of the life, your life. Let's say you're using, you're doing work as is that I described. It's very labor intensive. It's manual. It takes a lot of time. We significantly cut down time. Months of research and planning work. I'll describe how your process looks like today. Anytime you have to perform an upgrade, the very first thing you do is you'll get an email from EKS. New version is available, 133. You have to decide when to upgrade, so you plan. But as part of that, first you have to go look at your dependencies that are running in the cluster. You'll go run some kubectl commands or some scripts internally you have, or look at your Datadog dashboard or Lens and say, yeah, these are the things I'm running. Then you have to map all the dependencies. Once you've done that, then you go over each of those and figure out which of them is incompatible with the next version of EKS by reading their official documentation. Once you've done that, now you will go figure out what is the version you want to move to, and also figure out if that version is safe to move to or not. Then you will go and create upgrade paths or upgrade plans from the current version to the target versions for each of those. So it's like a recursive exercise. For each of those open source components, then you will also look at which of those components have application dependencies. For example, you're running Chkk. It's a stateful add-on. It's a very complex open source project that you have to maintain. If you're running it, most likely you also have internal applications which are using Chkk for authentication, authorization, other use cases. And let's say a new version of Chkk has a deprecation or removal in its Java SDK. Some function is getting changed. You need to know that is getting changed. You need to be able to identify that in your application stack and make sure that is changing in lockstep with your Chkk upgrade. So all that work is done. This is what I'm describing in the upper half. Once you do it, then you finally start rolling out changes in your staging, in your dev, staging, and prod. Chkk cuts down this research planning work, by months. And then even we help you with the execution of the upgrades and making changes. And this is something we announced yesterday on how you can go and make changes in your IAC, in a safe manner, which is contextualized to your environment. So, Carlos, I'm going to share my screen. I'll walk the team to how you can upgrade.
I see the word demo. Cool.
Perfect.
I see the magic, because a lot of people, and also I was mentioning I work in open source projects, be maintainer of different open source projects, and I can tell you, people know which projects I'm talking about. That in our projects we had jobs that did the upgrade of CRDs and things. We move CRs forward. So we told people you cannot just jump versions, because what we tested was the previous version when you do the apply, those jobs run and they will migrate the CRD or the CR or any configuration to the new schema, and we're going to upgrade them in place, right? So you cannot just jump over versions. That's kind of the same thing for Kubernetes. You cannot jump versions.
Correct. Before we do the demo of Chkk upgrade agent and upgrade MCP server with a coding assistant, I want to introduce you guys to a concept of an upgrade plan. An upgrade plan is something we've been doing and publishing for a long time now. Our customers use it, and now we are making it available to your native tooling like coding assistants. So what is an upgrade plan? You come to Chkk, you onboard your clusters once they're up and running, or your open source projects when they're running. You come and request a template or a plan. We'll skip that for in this meeting for now. You select it's in place, it's blue-green, it's rolling. You select an owner. Once that is done,
so you connect the clusters to your SaaS, right? It's like a simple connection of like now they're sending metadata, or like that metadata about what software is installed goes to the Chkk management system.
Absolutely. There are two ways to do it. One is we give you a Helm chart you can install in the cluster. The other one is you can use Chkk CLI, which is where you don't have to install any cluster. It's like think of it like
I can run it in my I'm a transporter with the CLI. That for some organization that's needed, right? Because they don't want to run something in the cluster, but just like run it as a CI or a job, right?
Yes, you can run in a CI. You can take CLI. You can run it, in any place. You don't have anything running in the cluster, and you
run it in the cron job. Go the old way.
Cron job, and that is they only run it when they need to upgrade, right? If it's right before that, and that's
when they need a plan, right?
Exactly, when they need a plan. So now they say, okay, it's in place, blue green. I already have plans, generated here, so I'm going to quickly show you. It's very dense. There's a lot in here in these plans. So I'm going to quickly describe how to understand a typical upgrade plan. To understand it, you have to understand two key abstractions here. What you see on the horizontal axis is called stages, and each stage has one or more steps. It describes, what is changing in the infrastructure, in your node groups, in your IAM roles and permissions. It tells you which of these add-ons you're running, and which of those add-ons have to be
Yes,
upgraded.
the IRAM and Q, the Istio, typical suspects, right? In open source,
Absolutely.
A lot of people use them.
External secrets operator. It also tells you which add-ons do not need to be changed and why they don't have to be changed.
Do not touch them.
It tells you all of that. Anything that is changing in your, application client side, and there's a bunch of other things, in this upgrade plan. To date, our customers were using it as a running workflow, and they would open tickets and they would go and copy commands from here. For example, I have instructions on how to upgrade cert manager.
I see.
Right, and I run pre-flight checks first.
Yeah, put this in Jira, right? Like this is our work. Next week, what are we going to be working on? We're going to be doing research, or we're going to do actual upgrades, and we check like we want to work on upgrades, not the research.
Absolutely. So we were running pre-flight, post-flight checks, and you would get exact diffs, what is changing between two versions. So you would go and apply it in your environment.
So this is the diff I was telling you about doing in the old way. We get diff to folders. You're doing that for me. That's Absolutely. Beautiful.
So it was all there. A lot of information here. Could be overwhelming for someone new, and our customers had some learning curve to go and start using it. In the demo, I'm going to show you, and by the way, we also publish these upgrade plans for individual open source projects like Cert Manager. This is what we're going to go and show you in the demo. It has the same abstractions. You have stages and steps, but it's only for one specific add-on or open source projects. This is for Cert Manager. It's moving from version 114.4 to 117.2. It's running on an EKS cluster, and EKS cluster is getting upgraded from version 131 to 132. Okay.
I see. So for organizations that have like hundreds of clusters, like lately I did a blog post that we released our EKS multi-cluster dashboard, right? I showed like 7,000 EKS Kubernetes clusters, but a lot of people have 100, they have 20, and there's something happening with Cert Manager. Like for some reason, we have to update Cert Manager, right? It could be a feature or it could be a critical bug. Where is Cert Manager running? Which version is it running in my clusters? In which region? In which account? What version of EKS there's Q? So this is concentrating, like, let's concentrate at least for this morning we're going to concentrate on cert manager, right?
Absolutely. So here, I mean, we're not going to cover this, in today, but we tell you every single add-on open source project that you're running, where are you running, how many instances you're running. If it's end of life, it's going to be end of life. It's incompatible. You see that all here, and we cover
the risk assessment, right? To tell the stakeholders what is the value that you get by using Chkk, right?
Right, and we cover more than 270 of these, open source projects today. In fact, our SLA to add a new open source project is 48 hours. You can simply come here.
Project. Okay.
You can request it here, and it will take 48 hours before it shows up in the product.
Yeah, but you have like the usual, I said, like the usual suspects, right? Most likely in the CNCF and ANSI open source, the fashion industry, like everybody's using the same projects. That's a good thing because it becomes a standard.
Absolutely. So today, I'm going to show you how to update my local cert manager Helm chart based on my running, infrastructure topology constraints, and that is, backed by our upgrade plan. This is just to show you this is the upgrade plan, and I'm gonna, this is running in an environment. It's an EKS cluster, which is getting upgraded from 131 to 132, and one more. And
thing I see the jump that you mentioned. Right, go back. I see something slightly there. It says current 1.14. The recommended is not 1.15 and it's not 1.14.5, right? That's tricky because if I need to go to 115 or the latest on 114 and then the latest on 115 and then actually I should have to do 16 and then 17 and then I'll be spending the whole week, right, going over all these things. Like that's the beauty of these two numbers, right?
Absolutely.
Am I correct or not? I'm just
100%. Look, latest is not the answer. The compatible stable version is the answer, and we look at several factors before we tell you which version to move to. We make sure this is not end of life. We make sure.
Oh, I see. So particularly it could be like 118 is not compatible with 131 or 132, right? Correct. Like you cannot go to 118 because it's compatible with 133, 134. Yes. And how do you know that? Like, who are you going to Google it? You're going to go to a blog post?
Exactly. Absolutely. And this is different for every single open source project. So you have to make sure it's not only compatible with your Kubernetes, is it also compatible with other add-ons? I'll give you an example. Istio and Glue Edge, they have their own compatibility. Cilium has compatibility with your operating system and kernel versions. Someone has to make sure it is compatible. So Chkk makes sure of that. With that, I'm going to share a different screen and walk you guys through how you can upgrade Cert Manager using our upgrade agent. Update the ISE of Cert Manager based on these constraints. So let me share a different screen.
There's people connected. People are like active. I'll have a question when we kick off the task. But this one is one that people are saying like.
The idea is that we want to kick off this agent. And then after that, we'll start looking at questions and answer those.
Yep.
So for those who are watching, it's very simple. You go to Chkk site, website, you click on coding assistance, click on install MCP. It will take you to the instructions on how to set it up. So, and there are getting started guides. All you have to do is
one sentence on what is MCP. Like I want to hear your version.
Model context protocol. It's a standard way for AI agents to communicate with each other. They can exchange tools, resources, prompts. It's a very, very powerful concept. It's a big enabler right now. MCP. It's funny. I was talking to a customer this morning, and we announced Cursor integration yesterday. And in the call, it's like I already have it up and running with Cloud Code. Because it's MCP.
Yes, MCP. It's a standard. It's a standard way of plugging into this AI world, right? It becomes the standard plug, and we don't have there's no problem with electricity or which plug, which country do I go and which plug do I get to? Like Absolutely. MCP is the only one. It's only one standard.
Look, we have built infrastructure already, right? We have the tools already. We have the capabilities already. These AI agents need an interface and a language to go and consume those tools, and MCP enables that. So we use our natural language to go and prompt these LLMs, and now they can go and communicate with our existing capabilities to leverage them, right? For example,
to your APIs, to the Chkk SaaS APIs. Okay,
exactly.
So good. I love your definition of the MCP.
Perfect. So I'm going to go and copy this command. We have an upgrade playground. I'll walk you through what that looks like. And I'm going to go and paste it here. It is going to clone the repository, and it's going to open this. I'm using Cursor right now, and soon we'll show you with other coding agents as well. For completion, I'm going to go and clean up everything so you can see everything from scratch. So I have MCP installed, but I'm going to go and delete it. So
this is the MCP.json, MCP server JSON, right? Typical that everybody is supporting. Even Amazon Q supports it.
So I'm going to click here. It's a one-click install. We have a deep link to configure Chkk MCP.
Okay, good. So, nice UX.
It shows up over here. Today we support local MCP. Eventually we'll support remote as well. There's multiple ways to authenticate with our MCP server. One is Chkk Access Token. We use device identities. We also support cloud identities. In this demo, we're going to use Chkk Access Token. I'm going to go and log into Chkk dashboard, which I think I already am. I'll go to settings. I'll copy a token from here, and I'm going to paste it here. Once I click install.
That's the only configuration for the MCP server?
That's it. Simple. So it's up and running. It has loaded the tools that this one needs. We have multiple MCP
And you're
servers.
using Docker, I see. The Docker, so using standard IO, right?
Absolutely. It's stdio, Docker. This is our first version.
Now for those nerds watching and they're MCP nerds like me, standard IO, this is a standard IO. Go ahead. And Docker, which is runs, you don't need to install Python in your computer, right? Most likely you have Docker.
Life is easy.
Or container runtime, like Finch, like it's a container.
It's multi-arch, so you can run it on different laptops.
But man, Docker, like as long as it spits out the standard output, that's the MCP protocol.
Correct. And now I'm going to go and I'll skip through a bunch of commands here. Please go. Feel free to go and read those. I'm going to go and prompt Cursor.
Can you make it a little bit bigger?
I actually don't know how to make it bigger.
Command plus.
Command plus, really? Oh, wow, nice, awesome.
Yeah, that's it. So what is this prompt looks like?
I'm asking Cursor that you are in a K8's ISE repo. It has to fetch an add-on upgrade agent from Chkk MCP. It has to upgrade the package, which is returned in the upgrade plan that I showed you already. And I'm saying, start by asking for an upgrade ID. So I'm gonna hit enter.
Very generic, right? I don't have to put specifics in here.
Yes, you don't have to worry about what version to move.
We don't have to say, sir. You didn't mention Cert Manager.
I did not mention Cert Manager. I said pick the package from the upgrade plan. Now it's saying, I can help you. Give me the upgrade ID. So I'm going to go back to Chkk, and let's go back to our dashboard. Let's go to the add-ons here. And for folks who are watching, what I'm showing you, you will be able to follow these steps exactly in your environment as well. So Carlos, we have, you see this little AI icon here? If you see this next to an upgrade plan, this means for this plan, we have the AI context generated, which means you can point your MCP to it, and it will be able to fetch the right context. If it's not there, it will not be. You can request it from us, but in this case, you can see these two have it available right now.
So that's an optimization, I would say, because typically what people build MCP servers, right? They connect to a existing API, like let's say pick up Asana or Salesforce or the Weather API. I've been doing the Weather API workshop. And then that's what you get. Like, and then you need to massage it and transform it and go back to the LLM to make it useful, right? It's a conversation, and that back and forth, it costs caching, right? You are doing optimization, so the answer to MCP is like one route, right? One answer. Is that correct? Yeah. I'm just trying to guess what's happening.
You're getting there. The context that has to be provided to the agent has to be in a certain shape, has to be published in a schema that the agent understands, and has to be, and we have designed it in a way that the agent does not end up polluting the context window unnecessarily. And that's the biggest thing, because the results matter, and we are operating in mission critical systems, and we don't want to,
hallucinate or not that the mistake, like somehow we get the version 116 and we were like, well, it was supposed 117.4. What happened in the conversation, right?
Yeah, exactly. And for example, like right now, it has to edit like thousands of lines of files, right? And if you load those thousands of lines of files in context window, the LLM will start sending ambiguous results, and of course, the agent will not be able to do a good job, and it will start skipping changes. It will say it's making changes, but it will start skipping changes. So we have seen those results. So we engineered and architected our system in a way that I'll show you. There's a powerful concept. So I'm going to copy this upgrade plan here, ID here, and I'm going to go back to cursor and say upgrade.
Oh, so what was the answer from here from the first prompt? Just a summary of what happened.
It says, give me the upgrade ID so I can start my work.
I need the upgrade ID. Oh, okay. Start by asking the upgrade ID. Okay.
Yeah. So I just gave it the upgrade ID, and it's going to go and start making the tool calls. Let's say, okay, I'll get the package info. It says, oh, I got the package info. This is Cert Manager version 114 to 117. And now it's loading everything that it has to do.
So it doesn't need the research, right? You were saying like doesn't need the research about the files that change. It's like this is the plan, the outcome. Like this is the you need to execute. You're using the LLM and Cursor or Amazon Q to help me as a human of like, well, how do I change which line and where corresponds? Like, how do I apply this patch? Do I run git patch or right? And so I don't make a mistake, right? Or accelerate to do it like in 15 minutes before lunch than the whole afternoon.
You can run this job. The plan already exists. The plan has been generated that you just saw like in the web app. And now you're asking your coding assistants via Chkk upgrade agent to start applying that plan, start making my infrastructure as code change while I go grab coffee, have lunch. It will take 15 or so minutes, and it's going to go and make all the changes that I can review. These are semantic diffs. We make sure if you have made customizations in your values.yaml or other places, the agent will respect that. And there are more than 10, 15 infrastructure as code patterns. So the agent will recognize what is the IAC pattern you're using. Either it's a fork Helm chart, or it's like a read-only Helm, or if it's Terraform, or Helm with customize, or GitOps. It will recognize those. Today we support fork Helm charts. In the future we're going to go and start adding more as well. So here, going back, it created a to-do list of the things.
So this is maybe we can take the question that it was in the chat that says mission critical systems with very low tolerances for outages, right? Maybe you only have one cluster, you cannot do blue green. So it's like, this is the cluster I'm doing the upgrade. There's no going back, it's going forward, right? Some customers have some clusters that are like that, or they don't have the maturity of having a CI/CD system of the blue green. So how safe is it to rely on an upgrade copilot that uses models such as Chkk's upgrade engine, specifically when AI agents are generating configuration stacks in the MCP context server? How can error probability be minimized given that loss cannot be eliminated entirely?
Great question. We built this for mission critical systems, and our product is designed for mission critical systems. The way it works is that you will connect your environment to Chkk, and we will get your raw information from your environment. Once we bring that in, we perform, we collect it, we map it to our knowledge graph. We have a knowledge graph where we model the relationship between every single open source project, that we cover today, their release notes, their EOL information, incompatibilities, all that you can think of. And then whatever we don't know, we infer, on top of it. We create like an inventory of what you're running. Once we have that, then we have jobs and engines which will go and help us, generate these upgrade plans, which are contextualized to your environment. We will tell you what are the contextualized release notes, and what are the contextualized pre-flight, post-flight checks, and what are the exact diffs. This is based on your ISC, your running system. Then from that point, Now, at this point, it's still a plan. We hand this off to your coding assistant to make changes in your infrastructure as code. There's no deployment yet. So you made changes in infrastructure as code. You review it as an engineer that, yes, Chkk made all the changes that it's supposed to make. Of course, we give you post-flight checks, we give you validation. Now you open a pull request and you merge and deploy it in your dev environment or sandbox to make sure everything's working fine. And then slowly you roll out to staging and prod. Now, in terms of how comfortable you feel with a system that will go make changes, Chkk does not make changes in your system yet, but eventually we will, and this is where it's heading. Today, we open a pull request. Tomorrow, we will also help you do updates on your non-mission critical workloads, and then on updates on lower environments like sandbox and stages. This is like a full self-driving journey where some are comfortable with level 5 and some of them are only comfortable with level 2. And that's exactly how it's going to be for a while. So you can come and select, yeah, cert manager in my dev environment, you can go use it. For others, I still need to babysit it.
There's another question. I don't know if you want to take it or not, or we'll take it a little bit later.
Let's take it.
So this one is interesting, right? So when you are upgrading, instead of upgrading clusters and applications, can we get first what app changes are needed and then upgrade the infrastructure as code? So that's the typical scenario where the platform engineers are, right? That we need to upgrade let's say Cert Manager. We need to upgrade Cert Manager to this version because there's a CVE. Like, we're going to get hacked if we don't patch Cert Manager. But if we update Cert Manager, the apps stop working because we have to make a change to the app first. Can Chkk help identify, like, well, if you make this bump to this Cert Manager 117, apps that are using this API in this way, they need to be, so make me aware of, like, oh, do I need to update the apps first so I can do it later, or I don't have to worry about it? Is that Chkk helps in this use case? I think that's the use case they're describing here. What do you think?
Absolutely. Let me show you a quick example here. Istio. This is a classic example. I'm upgrading Istio from 122 to 123, and the default tracing has been removed. And if you have any upstream configuration on the app side, which uses this, that can break. There's also consolidation of API versions. It's rare for someone to use protobuf, but if they are using it, that can break. And also there are removals in CNI Helm chart values. These are changes in your application side or the layers on top which can break. So now
here's a perfect example of, like, me being a purist will say, so it shouldn't be like Istio v1 to Istio v2, like, right? Like, no one in open source CNCF is creating v2s or v3s of anything. There's just like 121 to 123. There's a break and change. There's like some behavior change. Now suddenly I don't have tracing.
Correct. So everyone has a different definition in terms of what qualifies or what kind of changes are there. We have seen changes where in a patch version, the IAM policies changed in a patch version. And that has happened. So quickly show you how this is moving forward. So the agent ran it ran the pre-flight checks. It made sure the version that you're on in your local ISE is the same one that's running in the cluster. A bunch of metadata. It's telling you why you have to make these changes, right? It's Cert Manager has reached end of life, is unsupported. Cert Manager 114.4 is incompatible with your next version of Kubernetes. It's telling you what are the big changes between these two versions and certain features. Then it will go and start applying changes. There are 2 files being added. There are 23 modified and 0 deleted. So it's keep going. It's making all those changes as we are going through it. And it seems like it made all the changes, saying, post-flight checks.
I mean, when you say making changes, is editing files?
Absolutely. It's making changes over here. It edited all these files. It updated my, all the files that had to be updated.
Oh, so you have a copy of the Cert Manager Helm chart. And that's something that a lot of organizations, I know sometimes in Gov, they just I'm going to get a copy of that Helm chart and I'm going to put it in my Artifactory or going to put it in the Git. That I'm going to fork it and then maintain it there. Is that the pattern?
It's a contextualized change that we offer. An agent gets a scratchpad. It loads all the context over here. For example, in this scenario, the source is the upstream cert manager Helm chart. So that's being brought in. It's a package Helm chart. Another example is I'm not using Helm chart. I'm using the raw YAML, right? So in this case, Chkk will bring in the raw YAML, which is being used. It's not the Helm chart. Another one is I'm not using Search Manager Community Helm chart. I'm using Bitnami Helm chart, right? Or from someone else. Chkk knows about that and brings in that and make changes accordingly. For example, using Istio, you may have Istio from Tetrate, you may have Istio from Glue, you may have Istio from open source, right? And those are everything is Istio, but the packaging is different. The configuration may be slightly different, and all that contextualized snapshot of what needs to be changed is given to the agent so it can go make changes accordingly.
So the reason I ask is because people may think that what you're showing here is, or maybe getting confused of like, if it's as simple as updating the cert manager 114.4 to 17.2, I should go into Git Argo CD and say install Helm cert manager from their Helm repository to 117.2, and then my data is done. But you're saying like this is a slightly different concept that I have vendor 1.14.4 in my organization, and maybe I've made changes to some of the files. So I have my own version of Cert Manager 114.4. So I cannot just pick 1.7.2 because I need to bring all my changes, right, that are stored here. So this is doing the patching?
That's a very valid pattern. Let me quickly show you guys. So here, let's go here. What I'm showing you is forked Helm chart pattern.
Yeah, exactly.
Right?
You just describe my long sentence has a name.
Absolutely. You describe a GitOps pattern where I have an Argo CD app which points to a Helm chart. In that case, the agent will go and just change the pointer. That's all.
Okay. Boom.
That's it. So your Argo CD can go deploy it. And there are many patterns over here. You may have Terraform.
But sometimes the Helm chart from the open source project doesn't provide me my security ways for in the values.yaml to add my security context, or it doesn't provide me to add anti-affinity rules that I need to run in production. So I need to fork the Helm chart and just modify those type of things.
Exactly. So if you fork the Helm chart, this is what goes for you. Look, every team will make their own decision in terms of what ISE works for them. And our job is to make sure that whatever the ISE pattern they have in place, we make changes contextualized to their environment. And I've seen cases where people will take a Helm chart, will get a copy of it, will publish to their internal registry.
Artifactory, yeah.
Absolutely.
Or artifacts, in AWS we have artifact or ECR, push it to ECR.
Yeah. And some of them take Helm charts, then they render them, then they customize them on top of it, and then they apply them, right?
The render pattern where like I don't want to I don't want to depend on Helm. I just render the YAML files and I store that. This is exactly what's get deployed.
Exactly. So now you have all of those over here. So in this case, what I'm showing you in his example is just the forked Helm chart. If you have a different pattern, it will make changes accordingly. Over there, it doesn't have to go update all the files because it doesn't make sense. It only has to change the pointer or tell you, hey, you have to pull in the new chart.
So this is the value of the cursor, right? Or the MCP server with the AI agent, and I'm guessing using cloud model where the plan is saying you have to find this line or this code somewhere in this folder. And if you move that line around or you do changes, right, do your best to find that and apply the patch.
Correct. Yes. It's leveraging cursor, but cursor does not have, or Claude internally does not know what to change. It's great at understanding syntax. It does not know what files are to change. What is the content of those files? It does not know what version to move to. It doesn't know what was the source of this specific ISE. All of that is in the brain. And I think this is a good segue to explain to folks how this actually works. Like what is the behind the scenes and how we are able to provide this a relevant context at the right time to the agent so it can make those changes. I'll go back over here and bring my other slide deck, which is here. So the how it all works together, what powers this all is called collective learning. And in simple terms, collective learning has two key components. There's a component called Chkk knowledge graph. Another one is called risk signature database. The knowledge graph is where we model the relationship between every single project, their components, their packages, their package components, their relationships, the EUL information, incompatibility, release notes, you name it all. And in the risk signature database, think of it like a CVE for operational risks. We store known risks in there. For example, there's an upgrade advisory, which is not mentioned in change log, but we are aware of it. We build both of these by looking at exactly what you have to read. You read release notes, you read change log, you read official documentation, you read GitHub issues, pull requests.
Public information, right?
Public information. You have to do it, but it's so time consuming and you have to be an expert on every single topic to bring that in, and you have to stay up to date. So we use machines to bring that in. We also partner with OSS, the vendors and OSS communities, and our users also voluntarily report things back to us as well. And here we have watchers, researchers, curators, extractors, generators, and evals and validations in place to go and populate this. Whatever the machine.
So users provide that information once they find like maybe a very hard corner case, right? That is like in this case, jumping from this to this. Actually, this happened for us. Is you have users like providing that context, that
users
information
can voluntarily provide that. We do not automatically learn from the system. Users can come and report. For example, my Jupyter notebook is incompatible with my EKS version XYZ, right? And I learned about it.
Or Chkk not compatible with Argo CD, and like how else am I going to try that if I don't have it in my system?
Exactly. Right? So. And the other thing is we also have a Chkk research team. Their job is to go and keep the groundings, the source grounding up to date. For example, when
humans, okay, you have human labor for the system to keep it up to date.
Their job is to, when I showed you, you can request a new open source project and it takes 48 hours. That's where the research team will go and make sure our source grounding layer is up to date, which means, hey, this is a new open source project. We are adding MySQL. These are all the URLs. This is where the Helm charts are, and they set up the machine in a way now it's up
to start fetching the information about this project.
So someone with high judgment has to do it one time. Once it's up and running, from that point on, you can get update plans. You can get all the risk feed. Think of it like what you see in the diagram. Think of it like this is like a brain. The right side of the brain is where the collective learning is, and the left side of the brain is how we connect to your system. So I showed you a demo with the MCP. There's a bunch of other areas, of course, where we operate. And if I have to talk about how do we do how do we make all this context, real for you? This is where, hard engineering work has gone in to make it happen for you. When we take these raw artifacts from open source, right? We source them, we refine them, we enrich them with whatever information is missing. And that's where our jobs are running. That's where our agents are running. This is all in collective learning side. On the customer side, we collect your raw, artifacts like manifest and other things. We map them to what things are in the knowledge graph. Whatever we cannot, we infer based on different criteria. Once it's all done, then we contextualize that for your use case. Then we generate, in this case, for example, an upgrade plan or a risk workflow. We also do some pre-verification by.
And you do dry runs, right? Verifications. I think you do. People think like it's just this is the output and good luck with it. I think you run dry runs and verifications, right?
We provision a digital twin. We're gonna go and simulate this before this is published to you.
That's what I wanted to say, because I remember our conversation when we first met. You brought I think I was the one that asked the question, like,
yes,
how are you actually testing this? I'm not. I don't want to be the first one to test this. So actually you spin up infrastructure, right? Like cloud infrastructure, Kubernetes clusters with the enough configuration to mimic what the customer has, like the version of Argo CD, the version of Istio, and see if we can upgrade from 1.14 to 17, and then check if there's spots errors or if there's any logs errors, right? Is that the digital twin scenario?
That's the digital twin, absolutely. Of course, there are limitations. What we can do, for example, if you have a homegrown Kubernetes setup, we cannot go and
Yeah.
replicate it. But
But if it's say EKS, it's like one button like EKS 133. Give me one of those. Or we can EKS auto mode, one of those, and then install the Helm charts, the open source Helm charts on top of it.
And then you can plan essentially, and you raise PRs. And in today's demo and a talk, we showed you our new feature where how do we bring upgrade plans to your coding assistant. So the existing information that Chkk already offers, you can now have your coding agents and coding assistants make those changes on your behalf. I know we have 3 minutes, so I'll stop sharing my screen.
Yeah. So I want to conclude with something that maybe people have a question, or maybe I want to clarify is when people say I'm using Kubernetes or using EKS and I have add-ons, we have to be specific of which add-ons we're talking about, because in EKS, Amazon EKS, you can install add-ons like the VPC CNI, for example, CloudWatch, ADOT. Those are add-ons that you enable with the AWS API, something like Terraform or ACK or CloudFormation. And those add-ons, we are managing, we are installing them for you. So we know which version they're there. We do the CVEs. And then we also have upgrade insights. So we can tell you this type of information of like, you cannot upgrade to the next version of EKS 133 because you are like the VPC CNI is very, very low. Like you never upgraded it, right? Or the Kube proxy or core DNS. Like these are the add-ons that we manage and then we support there. The same thing for some of the community add-ons that we just added. We can tell you like this is not compatible, but that's just a handful. Then comes the CNCF ones, right? We have ESO, Argo CD, Istio, Linkerd, Chkk, all those things. We don't know what you're running in your clusters. That's a shared responsibility model, right? It's up to you to do that, and then that's where they can go to Chkk of saying, can you help me upgrade Istio, right? Argo CD, this open source project that I just happened to install as Helm chart or render Helm chart or Argo apps of apps. Like there's 16 ways of upgrading, installing that software because we didn't do it right. We install our software one way, and we know what it is, and then we are responsibility for those add-ons. But the open source software or system-wide software, which a lot of people call them add-ons, extensions to your cluster, that's something that Chkk is covering, right?
Correct. Absolutely. There's like EKS. I was part of the team that built EKS. EKS has done a phenomenal job at offering it, and it's designed to be the way it is. It gives you the flexibility. You can run any of these applications, open source software, where this entire ecosystem thrives, and there are thousands of people who are actively contributing to the open source communities. And because of the shared responsibility model, EKS will manage your nodes and your control plane and the manage add-ons. But anything on top of that, your applications coming from open source, you still have to be responsible for them. You still have to make sure they are maintained the same way a managed service is maintained. It's compatible. When you change one layer, you have to make sure the other layers are also changing in lockstep and remain compatible. And whatever changes you're making, you need to have a way to identify how to make those changes in a safe manner. And we become that co-pilot for you, and now we are offering you these agents which can even do more automation work.
Okay, great. So Fawad, thank you so much. We were planning this session. I was very excited, and also we delay a little bit because you are pumping out a lot of features lately, right? You even I forgot to mention, like you have a free tier, right? That people can try this today.
We have a free tier. Let me quickly show it to you guys before we finish. So all you have to do is go to Chkk website here.
So this is like for someone that is watching. We have a lot of people in the chat, right? If you want to give it a try for free, right, and then show the team and show the stakeholders, like we could spending a week of doing upgrades, or we can just spend half a day. Pick your medicine.
It's free to use. There's a lot of capability in our product which is free to use. You don't have to worry about it. All you have to do is sign up. Click over here. There's a CLI. If you don't want to onboard our agent, like
you are not allowed, right? You're not allowed to install this stuff in the cluster.
Absolutely. If you're not allowed to install, just use Chkk CLI. It runs locally.
which is new, right?
It is new. It's absolutely. It's like a week or so old. So we've launched a lot of. So yeah, you guys sign up, try via CLI, and get an upgraded assessment. Also, this demo that I showed you, you should be able to try it on your own, end to end in an environment.
Yeah, we have a few folks I think that are from your team that join. They're very excited about
responding. Thank you for
yeah, they have you covered in the chat. They're answering all those questions and they can do follow-ups. But yeah, I almost forgot about this, right? To show the CLI and the free tier and now the MCP server, right? Those three things you recently, like, that's why we delayed a little bit the show, to be able to show it to users on how they can do this on EKS. So if you have an EKS cluster, download the Chkk CLI, sign up for free, and give it a try, and you'll be surprised of the things that you'll find there, right? Upgrade plans, and say like, oh, I don't have to spend this time doing the research on what do I need to upgrade, or if I don't have to upgrade, hopefully I don't have to upgrade a lot of things, just the critical aspects. So thank you so much. Go ahead.
I promise you guys, you'll find something that I feel confident now at this point that try it out, you'll find something.
And how long it been the product have been out?
We launched our GA in October 2023, so it's going to be almost 2 years now. We are
in cloud native years. That's like almost 7.
Absolutely. And we have we are used by EKS, and we have mutual customers. We are used by enterprises across financials and healthcare, device manufacturers, and many others. And now we're making it super easy for even companies who have small infrastructure, right? You have 3 clusters, 10 clusters, you can go try it out. It's free to use. And please reach out to me directly. Just DM me on LinkedIn. If you have any questions, I'll connect you to the right folks. I'm happy to get a call as well. We are very, very excited to get this in hands of the customer and get their feedback.
Okay. Well, thank you. I think this was an amazing show. I'm happy that MCP and AI show up in DevOps. I'm doing a lot about AI DevOps engineering. And I thank you so much for the demos and your precious time joining us, and your team helping with the chat. They helped me today. So see you folks for the next show. I'll see you around. If you want to learn about Amazon EKS, or watch the other videos and subscribe so you can get notified when there's a new live stream. So thank you, folks.
Bye. Thank you for having me. Bye.